Okay, peeps, this is the chemical reactions packet, page 8. More practicing balancing. All right, so this very first one is a little bit hard, and it's written the opposite of how they've been written, with the water written first. It doesn't matter. It doesn't matter what order you write the two products or the two reactants. So you can see we're gonna need 6 hydrogens on this side, but if I put a 3 here, I'm gonna have an odd number of oxygens, so that won't work. So I'm gonna need to double this, take this up to 12, put a 2 here, so I have 12 hydrogens, and to get 12 hydrogens here, put a 6, and that gives me 6 oxygens here. Whoops, 6 oxygens here. My carbons, I have 12. To get 12, that's here. 12 times 2, it's 24. So 6 and 24, so I have 30 oxygens. So to balance that with 30 oxygens on this side, I need a 15. All right, number 2, the sulfates. There's this SO4 is a sulfate. There's 2 of them here, so I want 2 here. That gives me 4 sodiums. So I'm going to need a 4 over here. That gives me 4 iodines now, which is what I need. And the lead's the PB. The lead is already balanced. All right, this one, you can see I got 3 hydrogens here and 2 hydrogens here. They're never going to balance unless they both go up to 6. So let's see if this works. If I put a 2 here, that's 6 hydrogens, and a 3 here, that's 6 hydrogens. And now I can see this is not going to work because I'm going to create an odd number of oxygens here. I'm going to need to double all this so that this will be an even number of oxygens. So I'm going to double this to 4 and make 12 hydrogens here, right? 4 times 3 is 12 hydrogens. And double this to... Why double? Because you have to stay in even multiples. You have to stay in multiples. So this gives me 12 hydrogens here. And now that's an even number of oxygens here. 6 oxygens. 4 nitrogens. I need 4 nitrogens here. Notice I stopped working on the oxygens. Fix them a little bit, but wait until the end to finally fix them. So 4 nitrogens, that balances. So now let's check the oxygens again. So on the product side here, I got 4 and 6. I have a total of 10 oxygens. So to get 10, on the reactant side, I need a 5 there. Okay. All right, this hydroxide breaks up. So you can see there's 3 hydrogens on this side and 2 on this side. If I take them both up to 6, that would be 6 hydrogens, and this would be 6 hydrogens. This would also give me 6 oxygens. And notice I have 6 oxygens on this side. 3 here and another 3. So that balanced my hydrogens and my oxygens, and the irons are balanced too. 2 here and 2 here. Okay. Let's see. The nitrate is staying together. There's a nitrate and there's a nitrate. 2 on this side, but only 1 on this side. So if I put a 2 here, that balances my hydrogens. But hold on, we got more hydrogens here. 2 hydrogens here and another 2 here. If I put a 2 here, so 2 hydrogens here, 2 hydrogens here. So 4 total on the reactant side, and 4 total on the product side. So that's good. And what's the situation with this lone oxygen? I'm ignoring these oxygens because they kind of stayed together in the nitrate. I'm just going to pay attention to these. Can I balance them? This is 2 times 1, so that's 2 oxygens on this side, and this is 2 on this side, so that's balanced. All right, let's see. The PO4 is phosphate. It stays together, so they're balanced. Sodiums are not balanced. If I put a 3 here to balance them, I'll need a 3 here to balance to fix the bromine, and that just fixed the hydrogen. So that works. Let's see. This one looks pretty easy. 8 hydrogens on this side. So I can just put a 4 here to get 8 on that side, and 3 carbons here. I can just put a 3 there. All right, let's see, calcium's are already balanced, oxygens are not, manganese is, iodine's not. If I in order to balance these iodines, I'm gonna need a 2 here. So that'd be 4 iodines. And that unbalances my calciums. I have 2 calciums now, so I need a 2 here. And that fixed the oxygens. 2 times 1 is 2, and there's already 2. Okay. Let's see. So the irons are out of balance. If I put a 2 here, what does this do to my oxygens? There's 3 oxygens times 2, so the oxygens are 6 right now, and the hydrogens are 6 right now. Can I make them 6 and 6 on this side? If I put a 3 here, that gives me 6 hydrogens. What does that do for my oxygens? There's 3 here and another 3 here. So there's a total of 6. So they're balanced. Okay. Number 10, the carbons are already balanced. The hydrogens are not. There's 4. If I put a 2 here, there's 4 here then, and plus there's an additional 2, that makes 6. Okay, so that's balanced. Vanadium. We don't use vanadium very often. There's 2 on this side. If I put 2 on this side, that gives me 10 fluorines. If I put a 10 here, to have 10 fluorines, that also gives me 10 hydrogens. A 10 here gives me 10 iodines, which balances. Here we go. OS, that's osmium. We don't use that either very often. Or PT, that's platinum. The osmium is balanced. The platinum is balanced. The chlorine's not. Notice I'm ignoring oxygen. It's just a habit to do oxygen last. Often. It's the most difficult. The chlorines are not balanced, so I need to double this. And now that doubled my platinum, so I need a 2 here. That just fixed my oxygens. Perfect. All right, the carbons are already balanced. Fluorines are not. Double the fluorines, gives me 4. And the bromines are not. Double the bromines. There we go. All right, number 14. Mercuries are balanced. Iodines are balanced. Oxygens are not. I'm going to need a 2 here to give me 2 oxygens, but that also gives me 4 mercuries, which means I need to double the mercuries. So now I have 4 mercuries, but that just doubled my iodines. I now have 4 iodines, so I need to double them. Okay, and the last one, check that out, yttrium, we never use that. Okay, a lot of polyatomic ions here, which makes this look complicated. Plus there's a lot of symbols. There's gallium, we never use that either. But this one's actually not so bad, I can tell already. Actually, it's balanced already. See that, NO3? Remember NO3 is nitrate? It's a nitrate ion with a +1 charge. With a -1 charge. It's 2 nitrates here and 2 nitrates here. So there you go. And then here's the polyatomic ion phosphate. There's 1 phosphate here and 1 phosphate here. 1 yttrium and 1 yttrium, 1 gallium, 1 gallium. So it was already balanced. All right, that's it.